very much for joining this section. This is section 8.1, College Algebra, section 8.1. Today we would be discussing systems of linear equations in two variables. So we are going to start off with the systems of linear equations and their solutions. So systems of linear equations and their solutions. All linear equations can be expressed in the form ax plus by is equal to c. A straight line, the general form of a straight line can be expressed in this way. A solution, so there are kinds of solutions of linear equations. And so the first one is a linear. The first one is a linear system that has at least one solution. It's called a consistent solution. So the first one, a linear system that has at least one solution. Linear system that has at least one solution is called a consistent solution. It's just a consistent system. And a linear solution, a linear system linear system with a linear system with no solution. With no solution is called an inconsistent system. Okay. Let's start off with our first example. So this is example 1A. And it says, consider the system consider the system is 2x minus 3y is equal to -4 and 2x plus y is equal to 4. Right, so this is the system, and the question is, it says determine if the ordered pair If the ordered pair 1, 2 is a solution of the system. You tell me if the ordered pair is a solution of the system. So if the ordered pair 1, 2 is a solution of the system, then when we substitute the value of x and y in the equation, the outcome on the left should equal to the number on the right. So let's try and do that. So for 2x minus 3y is equal to -4. If x is 1, so we have 2 times 1 minus 3 times y is 2 is equal to -4. So we have 2 times 1, which is 2, minus 3 times 2, which is 6, is equal to -4. So 2 minus 6 is -4. So -4 is equal to -4. So it's true for the first equation. Let's look at the second one, which is 2x plus y is equal to 4. So 2 times 1 plus 2 is equal to 4. So this is 2 plus 2 is equal to 4. So 4 is equal to 4. This is also true. So since by substituting the ordered pair 1, 2 into the both equations, the number on the left-hand side equals the number on the right-hand side, we can say that the ordered pair 1, 2, the ordered pair 1, 2 satisfies both equations. 1, 2, and it's a solution of the system. Okay, let's look at another example, example 1b. And it says consider the system -2x minus 3y is equal to -4. And 2x plus y is equal to the same equation again, but this time determine if the ordered pair determine if the ordered pair 7, 6 is a solution of the system. Okay, so let's see, let's do similar, just check whether this is a solution. If it's a solution, if you substitute 7 and 6 into both equations, then the outcome on the left should equal to the outcome on the right. So for 2x minus 3y is equal to -4. If x is 7, so we have 2 times 7 minus 3 times y, which is 6, is equal to -4. So this is 2 times 7 is 14 minus 3 times 6, which is 18, is equal to -4. So 14 minus 18 is -4. So -4 is equal to -4. So this is true. It's true for the first equation. Let's check the second equation, which is 2x plus y is equal to 4. So 2 times x, which is 7, plus y, which is 6, is equal to 4. So 14 plus 6 is equal to 4. So 14 plus 6 is 20, and equal to 4 here is false. 20 is not equal to 4, so this is false. So the ordered pair 7, 6 is not a solution because it fails to satisfy both equations. So the ordered pair the other pair 7, 6 fails to satisfy both equations. Fails to satisfy both equations. Thus, the other pair is not a solution. It's not a solution of the system. All right. So let's discuss the various ways that we can solve linear systems. The first one is solving linear systems by substitution. Solving systems by substitution. Solving linear systems by substitution. So we're going to use an example to explain how to solve linear system by substitution. So example 2, it says solve by the substitution method. And the equation is 3x plus 2y is equal to 4, and 2x plus y is equal to 1. All right, so by the substitution method, what we do, we try to first express one of the equations in terms of either y or x, and afterwards we substitute that value into the second equation. So first of all, let's label this equation. This is as equation 1. Let's label this as equation 2. Picking equation 2 is 2x plus y is equal to 1. If we subtract 2x on both sides, then we have y is equal to 1 minus 2x. So now we want to substitute this y. We've written equation 2 in terms of y. So now we want to substitute this into equation 1. So we want to substitute this into equation 1. Okay, so equation 1 is 3x plus 2y is equal to 4. So now we have 3x plus 2, and y is now 1 minus 2x. So we substitute, in place of y, we substitute 1 minus 2x, and this equals to 4. So now let's expand. So now if we expand, we have 3x plus 2 times 1 is 2. 2 times negative 2 is 4x, and this equals to 4. So 3x minus 4x is negative x. So we have negative x plus 2 is equal to 4. And if we subtract 2 on both sides, we have negative x is equal to 4 minus 2, which is 4 minus 2, which is 2. And so now we are solving for x, so we can divide both sides by -1, divide this side by -1. So we end up with x is equal to -2. Now that we know x, we can find y. We said y is equal to 1 minus 2x. So y is equal to 1 minus 2 times x. X is -2, so -2. So we have y is equal to 1 minus -2 times -2 is +4. So y is equal to 1 plus 5, which gives us 1 plus 4, which gives us 5. One plus 4, which gives us 5. So x is -2 and y is 5. So now we can check to see whether our solution is correct or not. So the proposed solution is x is -2 and y is 5. So now let's check and see whether our solution is correct or not. So whenever we solve a linear system of linear equation, we have to check to see whether the solution is wrong. So one of the equations is, the first equation is 3x plus y is equal to 4. And we are saying the solution that we found is x is -2, y is 5. So let's substitute this into the equation to see whether it is true. So 3 times x, which is -2, plus 2 times 5, which is equal to 4. So 3 times -2 is -6, plus 2 times 5 is 10. This is equal to 4. So -6 plus 4 is +4. So 4 is equal to 4. So this is true. Let's check for the second equation, 2, which is 2x plus y is equal to 1. So 2 times x, which is -2, plus y, which is plus y, which is 5, plus y, which is 5, is equal to 1. 2 times -2 is -4, plus 5, which is equal to 1. So -4 plus 5 is +1. So +1 is equal to 1. So this is also true. So our solution checks out. Our solution is correct. Let's look at another way of solving linear equation, which is solving linear equations by the addition method, or sometimes it's also called by the elimination method, solving linear systems by addition. Solving linear systems by addition. And this is also sometimes called by the elimination method. So by the addition or elimination method. So the steps to solving a linear system by the elimination method is the first. Let me write down the steps. So first of all, if necessary, um, we should write the equation. We should write both equations in the form necessary rewrite both equations. Both equations in the form ax plus ey is equal to c. We should rewrite, if necessary, write the equations in standard form ax plus by is equal to c. The next is we can multiply, if necessary. If necessary, multiply either equation or both equations by appropriate non-zero numbers. So that the sum of the x coefficients or the y coefficients sum to zero. Coefficients sum to zero. And so once we do this multiplication where the coefficients can sum up to zero, we can add both equations. And add both equations into one equation. Both equations in one variable now. And the next is we solve the equation in one variable. We solve the equation in one variable. And once we solve the equation in one variable, we find the solution for one variable. We can substitute it back into the equation to find the solution for the other variable. So let's use an example to illustrate it. So this should be our example. Should be our example 3. So this is solved by the addition method. Solved by the addition method. This is 4x plus 5y is equal to 3. And then 2x minus 3y is equal to 7. Okay, so these are the first two equations that we have. So we will label this as equation 1. We will label this as equation 2. All right, so the objective is to find a way to add these equations up such that one of the coefficients will sum up to 0. And so we can do this by multiplying one equation by a number or multiplying both equations by a certain number such that after that, if we add the two equations together, one of the variables would cancel out. So if we look at this equation, if we multiply equation 2 by 2. So multiply equation 2 by the number 2. We have a third equation, 4x minus 3y, or minus 6y rather. Minus 6y is equal to 14. Oh, sorry. Yeah, it's equal to 14. So this becomes our third equation. So we multiply equation 2 by the number 2. This becomes our third equation. So we see that the first equation has 4x. The third equation also has 4x. The third equation is equation 2 multiplied by 2 also has 4x. So you can see that if we subtract equation 3 from equation 2, we subtract equation 3 from equation 2. Let's try to do it. So uh, equation 1 is, we subtract equation 3 from equation 1 rather, not 2. Equation 1. So equation 1 is 4x plus 5y is equal to 3. And equation 3 is 4x minus 6y is equal to 14. So if we subtract this equation 3 from equation 1, you'll see that 4x minus 4x means the x term goes to 0. We have 5y minus negative 6y. So we have 11y, and this equals to 3 minus 14, and that gives us negative 11. So we can divide both sides by 11, and so y is equal to negative 1. If y is equal to negative 1, we can substitute y into any of the equations to find our x variable. So let's substitute y into equation 1 to find x. Substitute y equals to negative 1 into equation 1. Okay, so we have equation 1 is 4x plus 5y is equal to 3. So substitute y is equal to negative 1 into it, so it becomes 4x plus 5 times negative 1 is equal to 3. So we have 4x minus 5 is equal to 3. So we add 5 on both sides, and that gives us 4x is equal to 3 plus 5, which is 8. And so now we can divide both sides by 4. And so that gives us x is equal to 2. So the proposed solution is proposed solution is 2 and negative 1. The proposed solution is 2 and negative 1. So let's check whether the solution is correct or wrong. All right, so let's substitute the values of x and y into the first equation. So first equation is 4x plus 5y is equal to 3. So when x is 2, we have 4 times 2 plus 5 times -1 is equal to 3. So 4 times 2 is 8. So 8 minus 5 is equal to 3. So 8 minus 5 is 3. So 3 is equal to 3. So it's true. It's true for the first. It's true for the first equation. Let's also check whether it's true for the second equation. So the second equation is 2x minus 3y is equal to 7. So 2 times x, which is 2, um, as 3 times y, which is -1, is equal to 7. So 2 times 2 is 4, so 4 minus 3 times -1 is 3, positive 3, so 4 plus 3 is equal to 7. So 7 is equal to 7. So this is also true. So the solution is correct. And using the addition method. So the next thing is let's discuss how to let's discuss the number of solutions of two linear equations. Any linear any system of two linear equations can have three kinds of solutions. So let's discuss what those kinds of solutions are. Um, okay, so the number of solutions. Number of solutions to a system. A system of two linear equations. All right, so there are three kinds of solutions. So let me write them here on the left. So the number of solutions. And so each solution also has a meaning graphically. So let me write that also here. So it says what this means graphically. All right, so one, it can have exactly one ordered pair solution. Exactly one ordered pair solution. And if the solution has exactly one ordered pair solution, it means graphically, it means the two lines intersect at one point. Two lines intersect at one point. It's also possible the linear system has no solution. And graphically, it means the two lines are parallel. The two lines are parallel. And number 3 is infinitely many solutions. Means graphically means the two lines are identical. One lies on top of each other. Okay, so this is how graphically it looks for an exactly one solution. If this is your y-axis, and this is your x-axis. The linear system, if it has exactly one solution, so you have two lines. So you have this is line 1, and you have this as line 2. They intersect at some point, and this is your line 2. If the system has exactly one solution, graphically, this is how it looks. It means the two lines intersect with each other. If the system has no solution, if the system has no solution, then it means the two lines are parallel to each other. So you have two lines which are parallel. They can go either left or right. So this is line 1. We have line 2. This is line 2. So if the two lines never intersect, that means the system has no solution, or they are parallel lines. And lastly, if the system has infinitely many solutions, if the system has infinitely many solutions, then it means the two lines are identical. So let's say this is your y-axis, this is your x-axis. You have the two lines lying on top of each other. So you have, let's say this is line 1 and line 2. They both lie on top of each other. So when we have this, we say the system has infinitely many solutions. Or the lines coincide. All right. So now let's look at some more examples and see whether we can identify the kind of solution of a linear system. So this will be our example 4. And here it says solve the system. Solve the system. Solve the system. 5x minus 2y is equal to 4, and minus 10x plus 4y is equal to 7. Um, so let's label these equations as equation 1 and 2. So 5x minus 2y is equal to 4 is equation 1 minus 10x plus 4y is equal to 7 is our equation 2. So we want to solve these two equations, and we can see that equation 2 has a 10. Equation 2 has a 10. Equation 2 all right, so let me move to another screen. Let's see. Okay, so okay. Well, let me write the question again and let's solve it. My other screen is misbehaving. So we have example 4. Says solve the system. 5x minus 2y is equal to 4 and minus 10x plus 4y is equal to 7. All right, so when it's not specified that you use a particular method, then you can pick any method that you prefer to solve the equation. So here I'm going to pick the addition method. I'm going to pick the addition method because I can see that the coefficient of the x in the, so this is first of all our first equation, and this is our second equation. I can see that the coefficient of the second equation is negative 10. And so if I multiply the first equation by 2 and add both equations, then I can get rid of the x in the resulting equation. So the step I'm going to use the elimination method. And so what I'm going to do is to multiply equation 1 by 2. So first thing is multiply equation 1 by 2. So if I do that, then I'll have 10x minus 4y is equal to 8. And so this will become my third equation. And now I'm going to add equation 1 to 3. So I'm going to add equation 1 to equation 3. So equation 1 is 5x minus 2y. No, I'm going to add equation 2 to 3 rather. I'm going to add, let me, this is a mistake here. I'm going to add equation 2 to equation 3 because the equation 3 is just the equation 1 multiplied by 2. So equation, I'm going to add equation 2 to equation 3. So let me write down equation 2 first. So equation 2 is minus 10x plus 4y minus 10x plus 4y is equal to 7. And equation 3 is 10x minus 4y is equal to minus 10x minus 4y is equal to 8. All right, so if I add equation 2 to equation 3, then the x minus 10x plus positive 10x, that goes away. And I have positive 4y minus 4y. So that also goes away. So that becomes a 0 here. And we have equal to 8 plus 5, which is 15. All right, so this is what I'm getting. So because I'm not getting a variable in this solution, we will say that this system is inconsistent. So we will say that the system is inconsistent and has no solution. So we write that the solution set will be an empty set. The solution set is the empty set. The solution set is the empty set. So this is one possibility whenever we solve a linear equation, a system of linear equations, right? We have three solutions that is possible. Either a unique solution, no solution, or infinitely many solutions. So in this example, it's a case where we end up with no solution, and it means the system is inconsistent, and the lines. Graphically, it means this. If we were to plot these two graphs, you would realize that graphically it will be a graph such that both of them never intersect. Both of the two lines never cross each other. They both go in the same direction, and they never meet each other. Um, so if we were to graph this, so generically it will look something like this. Both equations will be headed in a direction such that they both never meet. And it means the two lines are parallel. The two lines are parallel. The two lines are parallel. Yeah. So let's look at another example. So this should be our example 5. And we say solve the system. Solve the system x is equal to 4y minus 8 and 5x minus 20y is equal to negative 4. All right, so the first thing is let's write both equations in standard form. So the first equation is already in standard form, so it's 5x minus 20y is equal to negative 4. So this is our first equation, and this is our second equation. All right, so since the first equation is already given to us as x is equal to 4y minus 8, using the substitution method here will be easier because we can express the second equation all in terms of y. So x is equal to 4y minus 8. So we can substitute that into equation 2. And so that will give us 5 times 4y minus 8 and minus 20y is equal to negative 40. So 5 times 4 is 20y. So 20y, 5 times negative 8 is negative 40. And minus 20y is equal to negative 40. And so 20y minus 20y is 0. And so we end up with negative 40 is equal to negative 40. Well, this is a true statement. Negative 40 is equal to negative 40 is a true statement, but we don't have a y. So we don't have, so we will say that the system indicates that the solution has infinitely many solutions. So remember in the last example, one side was 0 and the other side was 15. So in this case, we say the system is inconsistent and has no solution. But in this case, in this example 5, we have both sides being equal to negative 40. And this is a true statement. So we say that the true statement indicates that the system has infinitely many solutions. The solution sets may be expressed as x is set that x is equal to 4y minus 8, or x is said that we have 5x minus 20y is equal to negative 40. So it means that two equations represent the same line. So we have infinitely many. Whenever we have infinitely many solutions, means the two equations, represents the same line. Okay. So graphically, it's going to look something like this. We have two equations, one on top of each other. So the two equations represent the same line. So graphically, this is how it's going to look like. All right. So let's look at some other application, examples that involves revenue and cost functions. So let's go to the next page, and here we're going to look at revenue and cost functions. Revenue and cost functions. So first of all, we see that a company produces and sells X units of a product. The company produces and sells X units of a product. The revenue function Rx is equal to the price per unit sold equal to the price per unit sold times X, and the cost function is given by Cx is equal to fixed cost plus the cost per unit sold times X. And the point of intersection of the revenue and cost functions is called the break-even point. So the point of intersection of the graphs point of intersection of the graphs of the revenue and cost functions is called the break-even point. All right, so let's use an example to illustrate the revenue and cost functions. So this will be our example. So this should be our example 6. And it says a company that manufactures that manufactures running shoes. Has a fixed cost of 300,000. Additionally, it costs $30 to produce each pair of shoes. They are sold at $80 per pair. And the question is, it writes the cost function. Write the cost function C of producing X pairs of running shoes. So the cost function is equal to the fixed cost plus, so we learned from the previous slide that the cost function is equal to um, the fixed cost plus the cost per unit sold times X. So if we look at this problem here, the cost function CX is equal to the fixed cost, which is 300,000, the cost function will be equal to the fixed cost, which is 300,000, plus the number of units sold times X. And so we are told additionally it costs $30 to produce each pair of shoes. So the additional cost per unit is 30, and this times X will give us our cost function. B, it says write the revenue function. Write the revenue function R from the sale from the sale of X, from the sale of X pairs of running shoes. So the revenue function is equal to the price per unit sold times X. And we are told that a unit sold is $80. So that means the revenue function Rx is equal to the price per unit sold 80 and times the number of units X. Okay, so the next is we are being asked to determine the break-even point. So C says determine the break-even point. So determine the break-even point. Determine the break-even point. Determine the break-even point. And describe what what this means. Describe what this means. Right. So the break-even point is the point where the cost and revenue equals to each other. Right. So the break-even point is the point where the cost and revenue equal to each other. So the break-even point, um, the break-even point um, is when the graphs of C and R intersect. Um, so it means we can find the break-even point by so our cost function Cx is equal to 300,000 plus 30x, and our Rx is equal to 80x. So our break-even point is the point where these two equations equal to each other. So we can set these two equations equal to each other at the break-even point. So 300,000 plus 30x is equal to 80x. Is equal to 80x. And so if we subtract 30 on both sides, 30x on both sides, we have 300,000 is equal to 80 minus 30x, which gives us 50x. And we can divide both sides by 50. And so we have x is equal to 6,000. So 6,000 units represents the point where there is a break-even point. And so at the break-even point, the number of units sold is 6,000, and the revenue at the break-even point, revenue at break-even point, revenue is equal to 80 times X, so equal to 80 times 6,000, and equal to 180,000. So at the break-even point, so the break-even point is at the break-even point, the number of units is 6,000, and the revenue is 480. The revenue is 480,000. So this is the point where the company will break even. That means their cost will equal to their revenue, and they can achieve this by selling about 6,000 pairs of shoes. All right, so this is where we will bring today's lesson to an end, and we shall continue in the next lesson, in another video. So thank you. Bye bye.